Okay, well now we will discuss integrals of vector valued functions. And here we go. So to compute the indefinite integral, remember the indefinite integral means we do not have limits. So we have the integral of r of t dt is equal to, you probably expect that we integrate each component separately. So for a function in 2 dimensions, we have the integral of f of t dt times I plus the integral of g of t dt times j. And of course, we do not want to forget the arbitrary constant, but in this case, since we're dealing with vector valued functions, our arbitrary constant is actually an arbitrary vector. And similarly, if we have a function in 3 dimensions, then again, we just integrate the components just like we did. And again, add in our vector valued arbitrary constant. To compute the definite integral, we basically do the same thing, right? Like literally carbon copy, except we don't need the arbitrary constant, but we do need the limits. And so I would like to just do an example. Let's evaluate r of t, where let me try that again. Let's evaluate the integral of r of t dt, where r of t is the vector valued function given here. So to compute the integral, we are looking at the integral of t cubed dt times I minus the integral of 2t over t squared minus 1 dt times j plus the integral of cosine of 3t dt times k plus our arbitrary constant vector. So we have 1/4 t to the 4th times I minus, now for the second integral, we can use a U substitution. Alternately, if you notice, the derivative of t squared minus 1 with respect to t is 2t. So really what we have is natural log absolute value of 2t minus 1, and that's times j. And then the integral of cosine 3t is 1/3 sine of 3t. That's times k plus our arbitrary constant vector c. And that's all there is to it. And last but not least, we have some suggested exercises. So next time we're going to talk about arc length and curvature and some other stuff. Well, actually, that'll be separate videos, but the next video will be on arc length. All right, have a good one. I will stop recording now.